No.
Okay, so most of what we're going to do today, you have probably already heard at some point. I may add a few things that you are not aware of, but we're going to talk about classifying triangles. We're going to talk about the triangle sum theorem. We're going to talk about the exterior angle theorem, and we're going to talk about isosceles and equilateral triangles and solving using what we should know about those two types. All right, so the very first section on your Chapter 4 test is going to say classify a triangle by angles and sides. So if I want to, what is an equilateral triangle?
All sides are equal.
Okay, a triangle with three congruent sides. A triangle with three congruent sides. Now, at some point in your elementary or junior high career, they spoke about isosceles triangles. What did your teacher in elementary or junior high tell you an isosceles triangle was?
Two sides are equal.
Okay, so now you've kind of grown up. You're in high school now, basically. And so we need a little bit better, more precise definition. So an isosceles triangle is a triangle with at least two congruent sides. And the reason it's at least is an equilateral triangle is an isosceles triangle. It's just a special type. Now, when I'm asking you to classify it, I want its most specific name. So I'm not going to write mammal, I'm going to write dog. Or I'm not going to write, if it's a dog, I might write German Shepherd or whatever. I want the most specific name. So when I classify, even though an equilateral triangle is technically isosceles, we're going to write equilateral if that's what it is. Okay, and then scalene has no congruent sides. So we get to our first section and we see number 1 is equilateral. And we see 2 is isosceles. And we see 3 is 3 something else too? It's a right triangle. What do we know about 8, 15, and 17? It's a Pythagorean triple. So we should know right off the bat that number 3 is also a right triangle. All right, for classifying by angles, I feel like you've done right, acute, and obtuse, but I'm not sure if you've done equiangular. So an equiangular triangle is a triangle with all angles congruent.
So the same thing as equilateral?
So if you write the word equilateral, then you're going to have to write the word equiangular. Because if all of the sides are congruent, that means all of the angles are congruent. And then I heard Brantley say something else. They're all 60. So if I know that my triangle is equilateral or equiangular, then I should know without it being marked that the angles are 60 degrees. An acute triangle has all angles are acute. So technically, an equiangular triangle is also an acute triangle. Because if they're all 60, then it's also an acute triangle. But we're going to write the most specific that we can. Okay, what about right? One right angle. We should know, we're smart enough at this point to know you can't have 2, because then we'd run out of degrees. And then obtuse is one obtuse angle. So when I look at number 4, What kind of triangle do I see?
Obtuse.
Obtuse. Number 5, I see
Acute.
acute. And number 6, I see
Right.
right. Bless you. All right, I want you to do 7, 8, and 9, and you should be writing 2 words for each because it says classify by angles and sides. So you're writing 2 words for each of these. All right, number 7. What kind of triangle by angles? Equiangular. And if you write equiangular, you have to write what? Equilateral. Even though there's not a 3 there, I should know that it is equilateral. Okay? All right, number 8, by angle.
Wait, how's it equilateral? I thought.
Because if it's 60 degrees,
Oh well.
then I automatically know
So
all
if
the
it's,
sides.
so if it's equal angular, then it's always equilateral.
Correct.
Correct.
And vice versa. If it's equilateral, it's always equiangular. Okay, what kind by angle for number 8?
Scaling.
Right.
Scaling. So.
And then
Scaling.
scaling. How do I know it's not isosceles?
Because it's a hypotenuse.
But how do I know that's not 7?
Because it's not.
Just it can't be. It's too long.
What would those angles have to be for it to be isosceles?
75.
Equal. They have to be equal.
They'd have to be equal. So could they both be 75?
No.
What would they have to be?
They have to
I
be
don't
both
think so.
30.
45.
Yeah.
The only type of triangle that's right isosceles would have to be a 45, 45, 90 triangle, which we're going to talk about in a minute. Some of you have heard about last year. All right, number 9. If this is 100, we know this is 80, so this is acute. All right, acute what?
Isosceles.
Isosceles.
Well, it doesn't matter which one you write on.
No. On the test, I usually put a blank for angle and side. All right, I feel like you can do that, so I'm not worried about doing all the rest of those, but I would like for you to go down to the very bottom of this page to the matching section. And I want you to take just a second, and I want you to match. If it says side lengths, you should be picking a word that has to do with side lengths. If it says angle measures, you should be picking a word that has to do with angles. All right, number 10. What about side lengths 6, 7, and 8? Scaling. 9, 10, and 9. Isosceles. 35, 55, and 90.
Right.
13, 27, and 140.
Twos.
And then we have a cube. Okay? All right, go to this next page. A vertex of a triangle is a point that joins the two sides of the triangle. So like A, B, and C here, those are vertices. A is a vertex, B is a vertex, and C is a vertex. That join the two sides of a triangle. The side across from an angle is the opposite side. Now this becomes important when we talk about isosceles triangles in a minute. So what is the side that is opposite angle A?
B.
CB or BC. So it's a line segment. Put the line segment on top. So BC is opposite angle A. Okay, what's opposite angle B?
AC.
AC.
C making that connection.
And opposite C?
AB.
AB. Okay, and that's going to be more important in a minute.
Order of the letter.
Does not matter. Okay, the triangle sum theorem is a very fancy term for the sum of the angles of a triangle is 180 degrees. The sum of the angles of a triangle is 180 degrees, which you already knew before you walked in here, because we've talked about it and you probably knew it in 5th grade. So the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 for this to be a triangle. So if I'm working example 2, I'm going to add those together and I'm going to subtract from 180. And what am I going to get? 52 I hear. Do y'all like 52?
Who said it?
Allie said it.
Oh, I'm guessing it's
You're
right.
going with Allie?
I like it.
Okay, so y'all could have done that before you walked in. Now let's take a second and let's talk about a corollary and what corollary means. So corollary comes from like, these have a correlation with one another. So they have something to do with one another. So a corollary, a theorem is a rule, okay? Pythagorean theorem. It's a rule that works every single time. A corollary to a theorem is a statement that can be made. Sorry, you're probably going to run out of room. Based on a theorem. So a corollary is not a rule, okay? A theorem is a rule. It works every single time. And a corollary is a statement that can be made based on a theorem. This theorem is true, so I can make this statement. So there are lots of corollaries for each theorem. So for example, don't write this because this is not the one that we need. So a corollary to this triangle sum theorem might be a triangle can only have one right angle. And I know that because if all three have to be 180, and then I can't have two that are 90. So that would be a corollary based on this theorem. But that's not the corollary that we need. So the corollary that we need is if a triangle is a right triangle, if a triangle is a right triangle, then the sum of the two other angles is 90. If a triangle is a right triangle, then the sum of the two other angles is 90 degrees. So if this is angle 1 and this is angle 2, then the measure of angle 1 plus the measure of angle 2 has to equal 90. Now, the reason that this is a thing and why do we need this is if you have a right triangle, technically for example 3, you could add 90 and 38 and subtract from 180, but it would be easier to just say 90 minus 38, which is 52 again. Okay? So instead of adding these together and then subtracting, you should know that these together have to equal 90. So just do 90 minus 38 and get 52. Okay? All right, so let's go to example 4. Triangle ABC and triangle ABD are right triangles. Suppose that the measure of angle ABD, so that's this little guy right there, is 35 degrees. We're finding the measure of DAB and we're finding the measure of BCD. So take just a minute and get those two measurements. All right, DAB, that's this angle right here. How many degrees is DAB? 55 degrees. What about BCD?
32.
45.
That's awkward.
Oh, that's 35.
So, if this is 35 right here and this is 90, doesn't that make this 55?
Yes.
And isn't this a right angle? So doesn't this have to be 35? Correct. All right, number 1. What is the measure of angle 1 right here? 45 degrees. So let's take a little sidebar and let's talk about this for a second. So if I have a 45, 45, 90 triangle, okay, then that means it's an isosceles right triangle. And some of you last year learned about the side lengths of a 45, 45, 90 triangle. Do you remember what they are in terms of x? X square root of 2. So these are going to be equal, meaning they have to be the same thing every time, because if the angles are equal, then those side lengths have to be equal. So they're both going to be represented by x, and your hypotenuse is going to be represented by x square root of 2. Now, this is something you need to start memorizing. We're not quite there yet, but there's two special right triangles, and this is one of them. So the legs of a 45, 45, 90 are always represented by x. So if one's 7, the other one's 7. And then the hypotenuse is always x square root of 2. So if the leg is 7, what is the hypotenuse? 7 square root of 2. All right. We'll do more of those later, but I kind of wanted you to have just seen that. All right, go to number 2 and find the measure of angle C on number 2.
Measured and well,
Okay, so if I use this little triangle at the bottom, this angle should be 40, correct?
Yep.
So then if I use this big triangle, then this has to be 50 degrees. Okay, the angles inside the triangle are the interior angles. Interior angles. When the sides of a triangle are extended, the angles adjacent to the interior angles are the exterior angles. How many interior angles does a triangle have?
3.
So how many exterior do you think it has?
5.
Probably 3. So if I took and I extended this side out like this, and I created this angle right here, that's an exterior angle, okay? And there's 3 of them. You can extend out the side of a triangle, each side, and you would get 3 exterior angles. What do you notice about this interior angle right here and this exterior angle right here?
They're supplementary.
They're supplementary, they're a linear pair. So exterior angles always form a linear pair with an interior angle. Exterior angles always form a linear pair with an interior angle. All right, so what I'm going to do is I'm going to number this angle 1, 2. I'm going to make this one 4 just because I want to, and I'm going to make this angle 3. So write that down. 1, 2, 3, 4. Extend that side out. And those are going to be angles 1, 2, 3, and 4.
Can you make that inside?
Does it bother you?
Yes,
I thought it would. All right, tell me a true statement about angles 1, 2, and 4.
They
equal 180.
They equal 180. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 equals 180. True or false?
True that.
Tell me something you know about 3 and 4.
They equal
They are
180.
a linear pair.
They're a linear pair, so they also equal 180. The measure of angle 3 plus the measure of angle 4 equals 180. Now, I want you to go back to proofs for a minute. This is not a proof. We're not doing proofs right now. But just for a minute, if 2 equations equal the same thing, what can we do with those?
Subset of equal.
Set them equal to each other. So I could say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 equals the measure of angle 3 plus the measure of angle 4, correct?
Yep.
Because if they both equal 180, then they have to equal each other. All right, do you have the same thing on both sides?
No. One of them, yeah.
Angle 4. So I could subtract that out and get rid of it. And I'm left with the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3, which is the exterior angle theorem.
well,
So the exterior angle theorem states that the measure of an exterior angle is equal to the sum of the remote interior angles.
What's remote?
So remote is going to be the ones opposite it, the ones far away, the ones not connected to it. So angle 3 up here is equal to the sum of 1 and 2, the ones that are away from it. So if I extended this out right here and I made this angle 1,
So it's equal to the ones that don't make the way.
correct. So the measure of angle A plus the measure of angle B would equal the measure of angle 1. So that exterior angle is equal to the sum of the two angles that it doesn't make a linear pair with. So on example 5, the old way would be, well, you could add these together, subtract from 180 to get this angle here, then subtract that from 180 to get here. But now I should know that if angle 1 should just be 58 plus 72, which I think is 130. Now, this is on the ACT all the time, and unfortunately, you kind of forget it because you take the ACT at the end of 10th or 1st of 11th, and it's been a hot minute since you were in geometry. Now, for the example 5 problem, I could work it the old way. I'm still going to get the right answer. But the problem is when I get a problem like this, and I say that this is 2x plus 7, and I say this is 3x minus 6, and I say that this is x plus 9.
Wow.
And I can't do the add these together, subtract from 180 anymore.
You gotta,
Okay.
you gotta do 180 minus 2x plus 7.
So you'd have to say these two together add up to give me this.
Right.
Okay? I just made those up, so it may not even work. All right, so we obviously don't do this homework because we're going to do something different. All right, so I would like to finish up. I want to take a little bit of notes on isosceles and equilateral triangles. So the next time I see you, you've had all the notes for the week. So the next time I see you, quiz-ish, but it's open notes. So you can use all the notes that we took today on the quiz that we're taking next time. And then I don't see y'all on Friday. Correct? Correct.
Really? I'm calling him when it's time to ride.
Hey, meet us outside.
You pass that to your side.
I didn't.
You're
I can't be busy till I'm
You're not busy.
I'm not busy if you don't want to do it.
That's John, man. That's what I guess.
It's later. Can't go with me.
Bro.
Okay, did everybody get one?
Bro.
Thanks, babe. Okay, so this set of notes is going to focus on specifically isosceles and equilateral triangles. And we're going to talk about the things that I'm expecting you to know, even if they're not marked. Okay? So if I see isosceles or equilateral, I'm expecting you to know these things, even if they're not marked. All right, so it says, remember an isosceles triangle is a three-sided polygon in which at least two sides are congruent. So we're going to label this isosceles triangle. And the thing I like about this one is that it will, sometimes y'all think that the isosceles triangles always have to be facing a certain way. And that's not true, okay? So the vertex angle is going to be the angle that is formed by the two legs, and the legs are always what sides are equal. So the vertex angle is formed by the two legs, and the legs are always the side of the triangle that are equal. The base of the triangle is the one that's different, so it doesn't have to be on the bottom. So sometimes y'all think base means bottom, but the base is just the side that's different from the other two. The base is always opposite the vertex angle, and then these would be your base angles. And your base angles are always congruent. So the legs of the triangle are always congruent. The base angles are always congruent. So the isosceles triangle theorem states if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So, in triangle ABC, if AC is congruent to CB, if that's marked, then you should know that angle A is congruent to angle B, even if it's not marked. So if AC is congruent to CB, if those two sides are congruent, then the angles opposite that are also congruent. Converse means the same thing, we just switch the order. So this is going to say if the two angles are congruent, then the sides are congruent. So if I tell you that angle A is congruent to angle B, then you should know that AC is congruent to CB. So I don't have to mark both. If I mark the sides, you should know the angles. If I mark the angles, you should know the sides. Equilateral triangle corollaries. What was a corollary again?
Oh, like
I think it's like
the thing you can like say because of.
Oh yeah, because of the theorem.
It's like I can say this is true because there's a theorem that tells me this is true. So if a triangle is equilateral, then it is equiangular. Those go together. If a triangle is equiangular, then it is equilateral. I don't have to tell you both. So kind of like on that very first one, Billy asked, they only had 2 3s on there. But because it was equiangular, I should know the other one is also 3. And each angle of an equilateral triangle measures 60 degrees. So those 3 things I should know based on equilateral triangle theorem. Anybody know what triangle, or not triangle, what shape number 1 is?
diamonds.
Mm.
Rhombus.
No time.
We don't have diamonds in
It's a
geometry.
rhombus.
2 triangles.
It's a
Definitely-
parallelogram.
It's definitely a kite.
It's a rhombus.
Oh, it
It's a shape.
No,
For it to be a rhombus or a parallelogram, opposite
Yeah,
sides have to be parallel.
It's
Those
a
are
weird
not.
rectangle.
So let's look at how we're going to solve for x first. We don't know anything about kites, so we got to use this as 2 triangles. When you look at this problem, does 11x plus 10 equal 9x minus 26?
Nah. No.
Yeah.
Yeah.
I was
Yes
sitting
or
there.
No,
Yeah.
it doesn't. It's not pointing to the thing.
So
No, look at the thing.
these two are your equal angles because they're opposite your equal sides. So 9x minus 26 is different. So if I can't set them equal, what should I do?
Subtract it.
So I'm equal to 180. Wait.
It's gotta be 11x. No, it's gonna be 22x plus 20.
So we need two of those, right?
Yes, sir.
Oh, yeah.
Plus what?
Oh.
Wait,
9x minus
Plus 9x minus 26 equals what?
180.
180.
Wait, why do you need two?
Because there's two of them. One's right there and one's right there.
Oh, I didn't see that arrow.
So when you have an isosceles triangle, you're going to have two angles that are the same. And you've got to figure out which two are the same. So the 11x plus 10 angle is what you have two of. So I want you to go ahead and solve that for x, and then I want you to go ahead and do y as well.
Easy.
Decimals are numbers too. Don't discriminate against the decimals. All right. So what did you get for what did you get for x?
6.
6.
I got
6.
5.806.
It's not 6.
Yes, it is. It's definitely 6.
Ow. I just don't.
You were like this close.
I literally got that exam.
I even got one wrong a couple weeks ago. And I called it.
I get 6.
Oh.
That was a fluke.
Oh, that's actually it.
That's what I got.
Oh, no,
Yeah.
I forgot to add one.
Okay. So for the other one, what do we have two of? The 9y or the 7y plus 5?
9y.
Okay. So we have 7y plus 5 plus 18y equals 180.
Why do you have 2 of the 9y?
Baby,
Oh, God.
how many angles are in a triangle?
Oh, wait, I see it. Yeah, I see it.
Sure. Promise.
Think of it.
So that gives me 25y equals 175. So what does y equal? 7?
Oh, no. Yeah. Yep.
Y equals 7.
Okay, so you're going to try the hourglass one, but let me just make sure we know. So 28x plus 27 is this side. 40x minus 9 is this side. 30x plus 13 is this angle right here. And 15y minus 1 is this outside angle right here. Okay? So take a minute, and I want you to solve for x and y on this shape. Mm-hmm.
Like, where it says 40x minus 9, is that talking about the side?
Yes. That's what I just said. It's okay. Man, I guess I had put in birds and I just never did y'all's, but I just.
Is anyone else getting decimals or algebra?
I got a decimal.
Yeah.
The number on the right.
This 15y minus 1 is confusing me. I don't know what it's talking about.
15y minus 1 is the outside angle. It's the one that's outside the triangle. Are we ready or we need another minute?
I'm gonna be honest, I'm not for this.
Dude,
You should give you one.
he gave you 4.
No, you gave me like one and three quarters.
He gave me like, no, he gave me 2.
He gave you one.
2 is too many.
Yeah,
He has way too many. He has like 600 grams.
1 is too many.
He's 600 grams in caffeine.
Yeah, I had 600 milligrams of caffeine.
Milligrams, Charles.
Milligrams.
Milligrams.
Because that would be 1 pound of body fat.
Me and Jake, my heart rate.
It's like what?
Alright, are we ready?
I don't want to say you four.
It should have been higher.
How much is that? Say
Well,
something.
he knows how to do the first one, he just doesn't know how to do the second one.
Yeah, we already acknowledged that.
Alright, so 28x plus 27 and 40x minus 9 are sides. And they're marked equal, so 28x plus 27 equals 40x minus 9. So when I solve that, what do I get for x? What? 3? Y'all like 3?
I like 3.
Yeah, I like 3.
I like 3.
Now what should I do with 3?
Plug it in.
Plug it in.
Plug it in for the angle. So if I plug in 3 here, what does that angle equal? 103. How many degrees are left for the rest of that triangle? 77, right? So that means that this angle right here and this angle right here have to equal 77 together. Well, if I divide that by 2, I get 38.5. Okay? So then to get what's outside, I'm going to do 180 minus 38.5, which is what? So 15y minus 1 equals 141.5. And I believe you get 9.5 if I'm correct. Is that right?
Yeah.
Okay.
Do it.
All right. I want you to take a minute and you're going to try 3 and you're going to try 4. So see what you can do with 3 and 4. Elliot, we just went over the one you didn't know how to do, so I'll help you in a minute, okay? But turn it over onto the back and I want you to try 3 and 4.
What you said y was 9.5? I looked it up. Still got the same answer. I don't know how to do this one.
I don't think we try that.
So these two sides,
He's real.
that's what it works, so we gotta set those equal to each other. Well, why is it?
I know, I got it.
Oh, okay. So these two sides
Sure
are
you
equal,
do
so
this one.
we would set these equal to each other.
I won't pie. I know how
You should have gotten it equals 3.
We need 3 in my head.
Then
You're doing 3 and 4.
I don't know how to do
you would take
3.
3,
4, 4.
you would plug it back in here.
Is that one? Oh, we did not do that. So 90, 113.
This angle right there equals 183.
Where? It's all those
So
sides.
if that equals 183, what's left for the rest of the
Oh,
year?
yeah.
On number 4.
Oh, number 4, yeah.
Okay, so, well, if these two sides are equal, that should be 38.
Yeah, that was
4x.
That's inside.
2 equals 30. 4x equals. X equals 8.
Alright, so 38.5 is that. So to get out here, I would do 180 minus 38.5.
141.
X equals 8 on the number 4, right?
All right, so we're working 3 and 4.
We got it. Shay, do you have any tips for these 3 and 4?
Can I give him a tip?
Look for
Oh wait, is 8y minus 7 equal to 6y plus 5? Oh.
How?
they're marked equal. Those little angle markings mean that they're equal.
Well, did they have to have a 2 then?
Yeah,
No,
sorry.
they do not.
Does 8y minus 7 equal to 6y plus 7?
Was everybody here on Monday for their test?
I believe so. Yeah, always. On Monday. So, Monday on Tuesday.
I felt good about that test, but then again, like,
I feel good about that test, but I still felt ill.
I probably get a B. If I had to guess, I'll get a B. To be good.
I guess I didn't make it out.
If I had to guess, I made it 87. What do you go with that?
You shouldn't be contention.
I am.
It's not the mop up
Where do you go? Like, the start.
already got it. I'm not doing number 3 though.
Well,
I'm not doing it.
these two angles are equal.
What is that? Like what?
You just set them equal to each other.
Oh, thank you, son.
Oh, those two angles are equal. Oh, they are equal. Okay. Thank you. I didn't realize those were equal. Thanks, Charlie.
Are we good? We need some help to get started. What's going on?
Give me a sec, and I'll be perfectly fine. Y equals 6.
That's awesome.
Here we go. 48 minus 7 is.
So how come you didn't have to record
Because I have antibodies. So if you have antibodies or if you have antibodies or you're vaccinated and somebody lives in your house, you don't have to quarantine.
Maybe it does.
Is your husband like sick? You're like sick?
He's okay. He got the shots yesterday, the infusion shots, so he's better. What?
He's the antibody.
He is. He is.
He's
Did y'all hear the study about like teenagers taking the vaccine?
Mm-mm.
Apparently, like it's like it'll give you some. It's like there's like a chance to give you some disease.
There's something on all They're making like
We all
pill,
yeah,
Pfizer.
So number 3, you should have started with 8y minus 7 equals 6y plus 5. And what do you get for y? Okay. Okay, then what did you do?
Plug it in.
Plug it in. What do you get? 41. So both of these are 41, right?
You get.
So then I learned earlier today that the exterior angle theorem states that an exterior angle is equal to the sum of the remote interior angles. So this angle right here is technically exterior to those two, right?
Yes.
So that angle should equal 82 degrees.
Could you do a linear pair?
You can.
Yeah, that's fine.
And this triangle is isosceles, so that means that 4x equals 82. So what does x equal?
20.5.
Say it again.
20.5.
20.5.
Wait.
Yes, sir.
Okay, so on number 4, I'm expecting you to know that when you see these 3 marks, what kind of triangle is it?
Equilateral.
So that makes all of these
60.
60, which makes 4x minus 2 what? 30. So 4x minus 2 equals 30, so x equals 8. And it's an isosceles triangle, so that means that 7y minus 9 equals what? 30.
30.
I said minus, I meant plus.
It's all good.
So y equals,
20 or 3.
okay? So if all 3 sides are marked, I'm assuming that you know that each angle is 60 degrees, okay? All right, 5 through 9, no, 8 are homework, but you have time to do them now. So if you have started on them, great. If you have not, I want you working on 5 through 8, and then you don't have any homework. Next time, grade, but it will be open